Hello everyone, in this video I want to show you a simple way to get your code from a non-testable state to a testable state. I'm going to show you how to test something that interoperates with external systems, something that maybe doesn't seem very trivial to test. In general, I think this should be useful if you are new to software development and you're writing your first tests and you just want to learn how to make your code testable in the first place. We will be using Scala, but the ideas here apply to any kind of language, any kind of testing library. I'm going to be using Scala with munit, but as I said, it's all the same. Most of the testing approaches will use the same concepts. You will have tests, you will have suites of tests, you will have mocks, you will have fakes, and so on. Maybe we'll do a series on this in the future, but for now, let's just focus on just writing a unit test for something, just testing some code in isolation without any external systems, and so on. Without further ado, let's get to it. I'm going to lead you through an example. So in the example, I wanted to have something that's doing a relatively non-trivial task, but also doesn't take a lot of time to understand. So here we have a GitHub client. The whole program is just going to, the main class is just going to download all my repositories. We have some logic inside. It's going to make a RESTful API call to the GitHub API. And we have two parameters here. We have the GitHub token. This is just going to be used for authentication. We just need this so that the API actually responds to us with some information. And we also have the GitHub user, which is the user that we will be getting the repositories for. The token is set in my env.rc. This is a configuration file for a program called direnv. So whenever I go to the terminal with direnv integrated in my terminal, the token will be available. I'm not going to show it to you, but I get it from my config of my CLI tool. This is the command line interface for GitHub provided by GitHub. So in the program itself, let me just run this real quick. When I run this program, okay, now it's going to not, I need to set the GitHub user environment variable. I didn't prepare it for that. We can always implement some better logic for this to check it, because this, I think it's going to return a null. We could actually just make it an option, like get or else, just throw GitHub user not defined, something like this. And yeah, as a result, we got a list of my repositories. They're supposed to be sorted like these are the top 10 repositories by the amount of stars and the amount of stars, and there's also a number here. I did a quick hack here because I don't want to bore you with the details of how to paginate, how to get information from an API that has like pages and it tells you whether there's another page or not. I just know that I need 3 pages for my personal account, and it works for my profile. I'm just going to use this here, but if you want to develop this example further, you're more than welcome to. Of course, we have a case class that defines the repository. This is what we'll be fetching from GitHub. This is the exact names of the fields as in the API. I didn't want to customize this here, so we are using the convention that they use in the API. Normally, I would probably have a separate data type for the decoded information, or I would have a custom decoder. Here I'm using the defaults from Circe, the ones that are derived using codec as object derived. And this is happening automatically because this is Scala 3, but this also applies to any other Scala version. Like you could use semi-auto derivation from Circe. By Circe, I mean this library. So we construct an HTTP client using the IO effect type. If you're not familiar with that, no worries, I'll link some resources in the description. But basically, we build a client and we will be using this. This is an HTTP4S client. We'll be using this to make HTTP calls, just like that. So here we have some code that basically says, do whatever is inside this function 3 times with 1, 2, and 3 as parameters. This is what the page value will be. And also do this in parallel and combine the results. This is the flat part here. So every one of these will produce an IO with a list of repositories. So just give me a whole large list with like the results of all these calls combined into a single list. So when we make a call, we say that we want a list of repository. This is going to use this codec to decode the JSON response that we get from GitHub, the HTTP response into JSON, like parse it into JSON and decode back to a list of repositories. So we'll just take these two fields. So then we build the request. We have a get method here. We specify the base URI. Then we have like slash user slash repos and some query string parameters. Like this would look like this. Yeah, something like this. So this is not for my account. This is for Julien. He has great courses on Scala, by the way. I recommend that you check them out. I think it's called Functional Tower. I'll have a link in the description. Not Tower of Hell as GitHub Copilot tried to suggest. Yeah, I think they're really great courses. I've done some of that, watched through the materials. You should check it out. So we have this URL, but basically this will boil down to something like this. In my case, it'll be because, and yeah, this will be our URL here. We'll get up to 100 items per page because this is the limit, and pages, we have 3 of them in my example. And then we put in the token for the authentication or the authorization actually. So this is just standard HTTP syntax to add a header. I could also put this directly into the request this way, but I like to keep this separate. It's not working because it wants the URI. Okay, I would need to make this a normal function call and have a comma here. But yeah, this would also work. I just don't like this style. I think it's better to separate out the headers. So yeah, this is how we make the request. We give that to the client. The client gives us a list of an IO of list of repository as seen here. And then this is after all pages are downloaded, we flat map. So we put the result of what we just got to some more processing. And here we do the actual business logic. Like this is, from now on, this is completely pure. This part here is purely functional, all in memory and so on. So we just sort the results by the stargazer count. We reverse the list, we take the first 10 elements, so that these are going to be the highest rated ones. This isn't super efficient, reverse and take. There's a way faster way to get the top 10 items, but for simplicity of code. And then I add the indices and I build the string that we were seeing in the output here. And then I print each line of this using an IO. So how do we test this? Like, first of all, one way to test it is to just run the program, again with the user, run the program and see the result, and we have confirmed that it works. We have tested it for one specific input for one state of the repositories. If we got any other response, maybe if I run this way ahead in the future, I would get some other results, and possibly I would have to inspect the response, the result again. So it's not an exactly super efficient way to test because you have to do this by hand, manually all the time. Another way of testing this would be to have a program that calls this run method here and verifies what the standard output is, and builds a string that is supposed to be and compares the strings. That could also work, but then again, it's going to be very fragile. You also have to connect to GitHub. You would need some really complex machinery to actually intercept these calls if you wanted to do something more magical, like if you wanted to mock the responses. You would need some sort of proxy. I'm not even sure it's possible with HTTPS, but yeah, this is what you would have to do. So in the classical style, what you would do with this, you would probably start by separating out the business logic from any kind of effects, side effects, and external service calls. And these can also potentially be tested in the future in a slightly more difficult way, because to test your integration, you need an integration test, and these have some intricacies to them that we're not going to cover today. But basically, it's more difficult, it's slower to test with a real external system than just testing some logic like this. So today I'll be focusing on testing this part of the code because this is our business logic. Everything else, here is an implementation, an integration detail. The pagination here, I'm just going to ignore it completely. But if I was doing this for real, I would probably be testing that as well with some mock client possibly, or extracting this away as well. So to test my program, I mentioned before, we need some sort of pure logic that we can test, unit test, and this logic is going to be this basically. So first I need to separate out this pure part of the business logic from everything else, including this call here, this traverse here. And as it happens, I can use a trick. I can move this traverse to another flat map call. And now Let me just, so we have flat map. This is going to be map now because we have no effect here. So we are just transforming the effect of the previous call of this parflat traverse, which is an IO list. We are transforming the list inside of that. So I'm sorting and so on. We have this business logic here, and then we have this separate, this final flat map call. So really, I can just extract this as a function. In an IDE like IntelliJ, you can do this automatically, but in here, I'll have to do this by hand. So I create a new function like combine results. It'll take a list of repositories, and I'm going to return a string for now, or a list of strings actually. And I'll just do this. This is what I copy pasted. And yeah, we have this. Now I need to use it. So combine results. And this is it. So you'll notice that the first thing I did in order to test this code is actually refactor it. So I'm doing something that I need to do in order to be able to even call this kind of code in isolation. And yeah, refactoring is often going to be the first step if you are going to test a legacy system. There's a great book about this, about working with legacy code, and it mostly focuses on easy refactorings that you can make in order to make something testable. It's by Michael Feathers. I'll leave a link in the description. I really recommend that book for basically every software engineer. So yeah, we have this function here. In real code, I would possibly have some sort of encapsulation for this code, for all of this. I would probably make a new abstraction like a service that takes care of executing some kind of client call, some kind of parameterized function. Let's say it would be like GitHub service, something that would take get top repositories for user, something like this. And I would have an implementation that uses a client, an HTTP client, and makes these calls and hides all these gnarly details of how to do it. And only then I would call this from my main class, my main object. And this would also make everything much more testable. But for today, we're just focusing on testing this part. So I don't have to extract any abstraction here. So we have this combine results function. I'm just going to try and write some tests for it. I have a unit already on my class path. So all I need to do is create like a program spec maybe. You can call it program spec, program suite. It doesn't really matter. It's going to be a fun suite, I think. That's the syntax. And yeah, so what are the things that we can test? We have a function that takes a list and returns a list. So the first thing that I think of when I see this is, what if I pass an empty list? What do I want to get and what am I going to get? So what I think it will happen is I'll get an empty list of strings, and let's just quickly verify that. So combine results nil. So I'm going to do, just this pretty much. So I'm going to assert that the result of combining an empty list, well, this combine results is actually a pretty bad name, but maybe let's just call it get result. So when I call this with an empty list, I'll get an empty list back. So let me test that. Okay, so we got a successful result. It's a good practice to verify that your tests are actually being run. So to make them fail at first and only then fix them. So I'm going to add like a number here to the list. I'm prepending a number to the list. And so I have a list of 1 on the left side and nil on the right side. So this is clearly being run. And my shell broke for some reason. This happens sometimes. So yeah, we have the empty case. Now the non-empty case, I will get a bunch of repositories in here. Also, one thing that I just thought about, this 10 number could also be a parameter of this function. Let's make it so it's going to make it easier to come up with test data. So n, let's call it something like this, n, and here I'll have to pass this number. So let's just pass 10 again. But in my tests, I'll be using something else. So here I can even use 10. I could do something like something called the property-based test, and basically say that for all integers, whatever I give you, I want to get an empty list back, but I don't really want to get into property-based tests today. I'm just going to do like 5 or 10 or any other number. I don't really know what would happen for a negative number. We can check that. I think for take a negative number, we'll just return an empty list at all times. Sort by and reverse will not blow up, and I think it'll just work. But yeah, let's just skip that case for now. So this is one thing that I can test, and also now it would probably be a good idea to test how it behaves with a non-empty list. So let's have like 3 repositories. So maybe combine results with 3 repos. So we can try that again, get result. And I'll have a list of repository. And this is going to be, I don't know, I'm just actually going to use the real results here. This is always a nice idea for initial tests. When you have a legacy project, for example, and you don't really know how it's supposed to behave, you just want to know how it behaves, and you want to write tests before you actually change this. Like, for example, if you need to implement some new functionality, you probably want to make sure that you haven't broken the existing ones, the existing features. So one way to do this, if you don't have tests, is to write the tests. And you can just come up with some test data, see what the program outputs, and just read this as the truth and write the test for this. So this is going to be like a regression test in this way. So I'm going to actually take, let's say, 6 of these repositories. I'm going to use them as the test data, and they will want top 3, but I'm going to write them down here in a different order. So we'll have flawless with 36 stars, some other repositories. Let me just leave it to do here. And I will expect SAP, Slick Effect, and Brickstore, currently my top projects, to be the outcome. But at this point, I'm starting to think, do I really want to test this kind of sorting and reversing and list operations, basically, together with how I build the string? And I'm thinking maybe not. So there are several reasons to split this kind of code. First of all, it makes, like, if you have a large function, it makes it smaller, it makes it easier to understand, because there's less stuff to understand. It's that simple. And also the API may get simpler. Like, if I get rid of this, I'm not really going to get any more simplicity. But if I had like 10 arguments to my function, possibly by splitting it, I would reduce the amount of arguments. And that's always good for testing. You need less fake data to feed to your function to test it, and so on. And also the call sites may get simpler as well. So yeah, I think I will do this. So something like render results, I'll get a list of repository again. I'm going to return a list of string again. So now I'm going to remove this part here. The code is not going to compile anymore, but just a simple change will fix this part. Now we need to fix the call site. So get result is one step, and then we'll also need render results. But this is essentially it. So now I need to update my tests. Let me just comment this out for now. I think combine results here. This is still going to be an empty list. We can run the tests again to verify that. It's good practice to run tests all the time if you want to see quick results. This is going to speed up your feedback loop. So I'm just going to do that now. So get result. I need to pass a number here. So I'll say I want the top 3. And the expected result is going to be some sort of list. So for now, I think it'll break because I have this here. But if I give it just one repository, I think it's just going to show up in the result. Yeah, and this could actually be like its own test. Like, what happens if I just give you one thing? Actually, let's just do it with one repo. It's going to be something like this. And we'll have with 3 repos. And we will want still 3 outputs. But I'll need to increase the size of this list. So we have 6 elements. Let me just quickly fill in the numbers that I need, the data for this test. Okay, so we have some test data. I could actually reuse this list for a couple tests. So maybe let's do it. So many repos. The naming doesn't really matter for this again. And that's not the purpose of this whole exercise. And now I can come up with a value that I want to be the result of this. So clearly this one has the most stars. I'm just going to copy paste it. Then the next one is going to be Brickstore, and then Slick Effect. So yeah, Flawless didn't get a spot. I think we have an issue here. Something like this. and one more, yeah. Let me just reformat. So after Brickstore, we will have Slick, no, that's before Brickstore. And also Flawless is going to be at the very end, or not at all. So if my understanding is correct, we'll have this, that, sorry, this, that, and that. Let's run the test. Okay, so we got 3 repos. We can again break this on purpose to see if it still runs. That's always a good idea. And now we can quickly make like another test. You should probably come up with better names, but at this point, that's what I want to do. And I'm just going to say I want the top 2, maybe. This will just give me this. So one idea for a property-based test here would be that if I want n repositories, I'll get the same result as n plus 1 repositories minus the last one, for example, something like this. You'll need to make some assumptions about what n is. It'll need to be at most the size of this list, the many repos list, but this is what property-based testing would look like. And you'll notice that we still haven't tested anything about the rendering here. And the reason why I was able to, like, why this was a good idea to split my code, my function into 2, is that I can now separately test how the results are rendered without having to deal with how they are sorted, any of this logic. I don't really care about this anymore. So now I can just feed any list of repositories to my code, starting with this probably, and just not worry about the ordering, just deal with how this string is made. Also, I could split this even more. I could just leave this as a function that I want to test, and I would only need like maybe 1 test, maybe 2 tests for the whole thing, but I would be able to test how specifically this function, this lambda in here, behaves when I give it some input. But here, I'm just going to stay on this level. I'm going to test render results as a whole. So let's do it. So I'm going to give it like 6 repos, maybe. So when we call render results and many repos, we will get a string that's something like a list of strings that will be something like, yeah, let me see this. No, not this. I want to see the data. I'm just going to copy paste this for a second. So it's going to be easier to simulate, well, to come up with the string. So 1 flawless, 36 stars. And now I'm actually going to use GitHub Copilot. Yeah, this is going to just complete my code. And this is exactly what I'm looking for. And yeah, this is what I expect in the output. Let's just verify that it works, and it does. So I can now remove this. And I assume that if I had a different number, it would also work. Let's say we'll do 4 repos. I can even do something like this, take 4 and just, yeah, something like that. And it still works. You could also like copy paste these repositories or make a new list and like have values for each repository here, something like this. But I'm just going to reuse this big list. It's probably a good idea to put it on top of the test so that you see what test data is being used in the suite. So I'm fairly satisfied with this testing code. Maybe I also want to test render results with an empty list, and it's going to be fairly trivial. Just give me an empty list again. Okay, so at this point we have plenty of tests. We actually had 7 tests, 4 for the first function, and 3 for the second one. If we wanted to test like this many cases with a single function, we would probably need more tests to, like the more complex our function becomes and the more test cases we want for each part of it, the more test cases we will need for the whole thing, and that grows not even linearly, but it would grow quadratically because of just the complexity of the code that you're testing and the test data that you need to come up with and so on. So yeah, so we've successfully refactored code in here to be tested. We've tested it, but still maybe you want to verify that you are calling the right API, the proper API, or maybe you want to test that you are actually outputting the code on the screen. For these kinds of testing, you would need something else, maybe an integration test. Maybe you would test with a fake console instance. For example, here we have what IO println is. It's just it's actually console of IO.println. So maybe you would come up with like a fake console instance and test the output through that. Although I don't think there's much reason for code this simple. But yeah, maybe something like this. Maybe you would extract the code that works with a client, like maybe all of this even, and provide a client that's in memory that just forwards to some internal route. You can do this with HTTP4S. You would not use something like Ember. You would use just client from HTTP app, and you would provide this binding for this route possibly. Not exactly this. Yeah, I'm not exactly sure this is the right code, but yeah, you would use something like that. Or maybe spin up like a fake server next to your application, customize the base URL so that you can use a different host name and call that application, like this application next to you. This is going to be like a more heavy integration test, so it will be more expensive to run and take more time and be also more flaky possibly, like prone to timeouts and so on, race conditions. But you could also test this in a stateless way with a fake client. So there's many things that we can still test here, many ideas for testing. We could also get rid of this, extract some better interface for how you actually call this, instead of just calling run. Maybe we would have this service that I mentioned before. So many ideas here, many ways to approach testing this further, but this is what I wanted to focus on in this video. If you like this, I really encourage you to read that book that I mentioned on working effectively with legacy code. Yeah, in the future, if you like this kind of content, maybe we'll talk more about testing and refactoring in Scala or something else. Let me know what you thought about this video, and I'll see you in the next episode. So please leave a like, subscribe, and yeah, that's all I have. Thank you very much for watching, and I'll see you next time.